In this video, we're going to talk about how to prepare an image from Design 3D to be used as the starting point for a rendering in Envizia, using its 3D base to render function. This function uses a basic 3D rendering as the starting point for an AI-generated image. Here are key points to remember as you go through this video. 1. You don't want to use just a screen grab of a view that contains polygons, because the AI system will see all those polygon edges and try and interpret those as object features. Number 2, you want to produce an image that captures the contours of your shape or scene so the AI system can clearly understand them spatially. And number 3, we want to produce a clay type of image devoid of textures and color. So I've got a scene here in Design 3D that's like an architectural scene that I'm testing out. You can see I've done just a basic rendering. I've not tried to do any materials or lighting apart from this main global light. The idea here, as far as an intent to bring data over to Envizia, is to define the shapes and contours of the scene and the objects in the scene so that Envizia can have an idea spatially of what it is that you want to do. So you have to think a little bit differently about how you're lighting the scene. So we have the single light source coming in providing illumination, which might be interesting for a rendering, but it's not doing a great job of defining the surfaces and the contour of the surfaces. So we're going to think differently about this. So we're going to eliminate this main light source right here. So let's go ahead and close this rendering down. And we want to come over and turn off this global light altogether. And in fact, I'm just going to go ahead and delete that. And we're going to put in a horizon. A horizon is really sort of a good starting point for this type of lighting. So this certainly doesn't look like it's providing very interesting lighting, but there are a couple of ways that we can go about doing this. In some situations, you can just take a screenshot of the OpenGL view, the interactive view, but it still doesn't give us a great amount of information. So for instance, if I come over here and I rotate this, you can see that it kind of reveals some of the lighting, and like that's okay. That might work. You could certainly try just rendering an OpenGL or a metal view of your screen in this particular situation and giving that to the AI system, but it still isn't really exposing some of the topology very well. So I'm going to come back over here. Let's reset the rotation. And if we come over here and just do an interactive rendering of this, you can see that even that basic lighting is doing a decent job of providing surface contours and shading that the AI system can use. So doing a basic rendering like this with even just this basic lighting is a good starting point. So to produce the final rendering that we would give to Envizia, you just come up to Render Image. And what I typically do is this. I just come in, you set it to radiosity, and just go ahead and set here to the better. Just set all of these right down midline. That's a perfect starting point. And then you can use 2 or 3 bounces. That usually will work pretty well. We'll do 3. That will allow the light to sort of bounce around inside of the nooks and crannies a little bit better. And then just do something like 2000. You just want to give it large enough that you're capturing enough of the detail. And when we render, it'll do some pre-compute. And then it will start producing the final rendering. And there we go. So this took, I don't know, about 3 minutes to render, and it's got bounce lighting on the interior, and critically, it's just going to provide enough surface contour information for the AI system to understand what's going on. Now, the thing is that we don't have any sharp shadows really that are going to confuse it about what is a shadow versus a feature, for instance. So this is one way of doing it. So we'll go ahead and save this as a source. Now, there's another way of capturing this shading information that's actually a little bit quicker. So we just used global illumination that had 3 bounces, meaning the light would come in, strike a surface, bounce once, bounce twice, and then bounce a 3rd time. And when we look at the render engine, we can see that over here in lighting. We can see that it says radiosity bounces 3. But we can use what's called an ambient occlusion pass. An ambient occlusion pass is just sort of a fast way of determining how much light from sort of a global light source like the light dome actually hits a surface, and it can reveal nooks and crannies of a surface in a way that helps to define the surface topology, but it's a little bit quicker. So let's take a look at this other mechanism using a technique called ambient occlusion. Ambient occlusion is just a single bounce way of ray tracing a global illumination light source like this light dome that just basically captures the nooks and crannies, how much light gets into the nooks and crannies of your scene and across the surface. It's sort of a self-shadowing type of mechanism. So let's do this. Let's turn off the interactive renderer here, and let's come up to the render image dialog box, and we're going to disable radiant illumination. And this is going to tell Design 3D to use this ambient occlusion technique. So go ahead and click Done, and that will configure the renderer. Now we've got to come over here and specifically tell the renderer how to sample the light dome. Now the light dome could be something like an HDRI image that has some bright spots in one areas and dim parts of the image in other areas, and we can have it intelligently sample these areas. So what we need to do is come over here to where it says max samples, and we want to increase this. So you can see that it's got these longitude and latitude lines here that define regions on this sphere. And within each of those regions is this red dot. And that's the sample region of each of these regions here. So if we increase this to say 128, and then you have to force a redraw, you have to rotate. I don't know why it does that, but you can see now how it's divided this up into more sampling regions, and that'll make it more accurately sample the light dome. Well, in this particular case, this horizon doesn't change radically, and so we don't need a huge number of samples, so I'm going to leave it at 128. Now, the next most important parameter is the one here called shadowing, and that is the number of samples per each of these sample regions. And if it's too low, it'll look really grainy. So let's just go ahead and do a rendering now and take a look at what this looks like. So let's just come up here, do a render image. Since we've turned off this radiant illumination, it's now going to use this ambient occlusion sampling mechanism. This does not calculate light bouncing between surfaces. It's only calculating the direct contribution from the light dome itself. So when we click render, you can see it's going by a lot faster, and it will give us enough information for the AI system. And it's nice because you can iterate this pretty quickly. There it goes through the final anti-aliasing pass. And again, the key feature here that we're interested in is defining the surface topology without a lot of hard shadowing. We want enough shadowing that the AI system can read, say, a wall versus a floor, but those hard shadows from light sources is not what we want. Now it's a little bit grainy still, and so this is where we would come over. Let's not save this, and this is where you would increase the shadowing. So let's go to, say, 32 samples for each of those. And so it'll take a little bit longer because it's casting more samples, but it'll refine the image. But let's say that it still is a little bit dark. It still is a little bit dark in the interior because light isn't bouncing around between the surfaces. So we could come over here and we could increase the light dome strength to, say, 200. Don't worry, it's going to blow out the interactive renderer. But when we come back over here and when we do another quick test rendering, that'll just make the scene a little bit brighter like this. So that's one way of doing it. Now, the other way to do that is you could just come over when we click render here. And if you come over to where it says render gamma, you could also take brightness and you could punch in a value of 200 right here. And then when you do that, when we do another rendering, you can see how that really brightens it up. So you've got those two sort of mechanisms to play with in terms of brightening it up. And again, it doesn't need to look pretty on our end. We're primarily concerned with how well does it define the surface features of our model. Okay, so there's our preview. I think I'm going to draw back this to 150%, and then we'll do our final rendering. I'm going to do 2000 pixels wide, and that should be plenty of information for the AI system to use. So there we go. So we have our image, and it has captured basically all the surface topology and contours that we need. So now we can save this and bring it into Envizia. So now we're here in Envizia. Let's go ahead and load up the image that we had just generated in Design 3D. There we go. And let's put in our prompt. A hotel lobby with modern Art Deco styling, white marble walls with gold trim elements, white curved ceiling, black marble floor, early morning lighting, hanging Art Deco lights from the center of the curved ceiling, and then we generate. And there we go. Now you can see in the background, it's interpreted our word curve and it's added some elements here. We can very easily go into the remove function and just remove those quite easily. So I'll just go ahead and show you what the removed image looks like. So here is a watch, a couple of watch objects. Now, the first thing that we want to note is the fact that I'm looking at this in an OpenGL, like a hidden shaded view. And this would not make a good view to send over to Envizia because it's got all the polygon edges and lines. And that's one of the things you want to be aware of, is that it'll see those as features and it'll try and interpret those polygon edges as features. So we could come over and just press the G key to go into a smooth shaded mode, and that's better. Now, because it's a 3D based render, we could give it something simple like this. But one of the things that it'll struggle with is it will see this one that's on the ground. See, if we look at this, that from our standpoint is just resting on the ground, but it will have a hard time understanding the contact to a ground right there. So this is where having some of the basic shading information is going to be useful. Right now, my watch objects have materials that are assigned to them that I have set up for rendering in Design 3D, but we don't want to use any of those. And some of those materials impart color to the surface also. So one thing to note is that when you bring in a 3D based render, any color that you have in that is going to be ignored by Envizia. It's simply looking at shading information. So I want to come over here and give a basic material. So let's select that, and I'm going to type in clay, and we just want a really basic type of material with not a lot of features on it, sort of like that I've just applied there. And right now we want to run that ambient occlusion type of render too. So let's come over here first off and assign that a horizon. So let's just create a new horizon. And the default values are good. So I'm just going to go ahead and leave them like that. So it's a little bit over bright. Again, that's fine because we're not going to be using the interactive OpenGL view. Let's come over here also to our global light. Let's just, for right now, I'm going to make that construction so it won't impart anything to the surface. Now, if we just come over here and render, so we'll do a render image. Enable radiant illumination is off. Again, we're going to use this ambient occlusion type of render. And let's just take a look and see what this does for us. So it's pretty quick. And this is what we want. This is what I call a clay type of rendering. It just is enough to define the surface topology. Now, one thing to note is, let's say that you feel it's too dark in some area and you're not seeing much of the surface because it's too dark in some shadowing areas. This is where we could come over and re-enable that light. And let's just take this and maybe bring it down below. And you just want to turn off shadow casting, and it may not need to be very bright. So we'll turn off that. And then you can do another test rendering to see if it provides just enough illumination coming up into some of those darker areas below. So this is what you want to play with. I think what I want to do is maybe just decrease the intensity a little bit, and then we'll produce our final rendering. Now, if you look here, let's press the S key to go into outline mode. I have drawn a box around here, and that's the region that I actually want to render. It's unfilled. This is simply defining that render region. If you come over here and right click on that, you can see there's a render extent of this 2D polygon, and that will become our render region. So now I'm going to go up to 2200 pixels in width, and then we will render to produce the image that we send to Envizia. And there we go. So, in fact, I'm going to do one more. And the reason is, I think I'd like to differentiate this ground that it's on. The ground and the object are not differentiated much here. Let's do one more. where we come over to the ground object. I don't have a material applied to it, so it's using that default material. Let's come over and just give it a slightly darker ground, and that will help to differentiate. Let's come back over here, do a render extent. Let's go back to 2200. And then when we render this using that ambient occlusion process, which is a lot faster, there, that's better. We have much better definition now between the object and the background. And again, that will help the AI system. Okay, so let's go ahead and save this and bring it into Envizia. So here we are. Let's go ahead and just load that up. So we upload the image. There we go. And then let's increase our style strength. So it really kind of our image strength, so it pays attention to the shapes and contours. So there's always a bit of contention between the image strength and the creativity strength. How creative do you want it to be versus how close do you want it to adhere to your reference image? And we'll put in an expensive men's watch, brushed titanium. The face has a blue radial anisotropic face behind the watch hands. The watch hands are made of metal. The ground is black and shiny reflective, studio type of lighting. Okay, got that in, and now let's go ahead and generate. And there we go. So you can do really pretty quick visualization on a product like this to get a sense about how you may want to either use this, or maybe you want to go into Design 3D and set up lighting and shading and materials, but you first want to do just this rapid idea generation to get a sense for what it is that you want to do. So I hope you found this to be a useful tutorial for producing images from Design 3D that can be used in Envizia as a starting point.